This is homework 3 problem solving video. My class number is 2015000348. Therefore, the problems assigned to me on number 10 and 16. Among them, I solved problem number 16. Then, let's look at the problem and how to solve it. First, let's look at the contents of the problem. Problem 16. There are 20 communication lines connected to the online computer system. Each communication line operates independently of each other, and the probability that any one communication line is in use is 0.6. Find the probability that more than 10 communication lines will be in use at any time. The problem can be solved simply. First, let's look at the sample space. A sample space showing 20 communication lines being in use or not in use. One independently functioning communication line has a 0.6 probability of being used, and we can see that the probability of not being used is 0.4. Let's just look at what's come out so far. What is a good way to solve a case where n is 20 and p is 0.6? There are two ways to solve this type of problem. The first is to introduce the concept of binomial probabilities. Second, there is a way to introduce Poisson random variables. Which of the two methods is more appropriate? If n is a small value, it is good to use the binomial probability concept. Also, since the probability p-value is not very small than 1, it is also appropriate to use the binomial probability concept. Therefore, I introduced the binomial random variable x. At this time, the binomial probability variable x is called the communication line in use. So, the probability mass function for the probability of using as many as k of the 20 communication line is then as follows. At this time, k is an integer from 10 to 20. The reason for the definition of this k value is that more than equal to 10 communication lines must be in use. By calculating this probability mass function, we can get the values we want. In order to calculate the probability mass function, a sigma was attached to the front, and k was defined as 10 to 20. It can then add up to the probability that all 20 communication lines will be used, starting with the probability that 10 communication lines being used. If you add all the probabilities, you can get a value of this. If you multiply 100% to convert to percent, you can get our approximation value 87.2%. Therefore, the probability that more than 10 communication lines are being used is 87.2%. To compare whether this value is correct, I was calculate for the mean and the variance. A graph of 20 communication line, 20 averages, and 4.8 variance was shown. In other words, the graph was produced only by number, mean, and variance. Areas with an x value of 10 or more are painted blue. If you add all the y values in the blue area, you can get a value of 0.872. Converting this to a percentage is 87.2%. In other words, this graph is the same as the probability mass function graph. And see that we got the probability we want to get. This complete the problem solving. Thank you for a semester.